Hi, I'm Shikha. You're watching this video from justtutors.com. So here today we are going to learn about irrational numbers. Before that, it's a warm up for you. What you can do, just pause the video, try these two questions. Assuming that you have done it, now we can discuss the answer. So here is 5 square root of 3 a rational number or irrational number? So this will be irrational number, and in this one is pi a rational number or irrational number? So again the answer is irrational number. So since in these two they are irrational number because they cannot be written in the form p over q, where p and q both are integers and q is not equal to 0. So therefore they are irrational number. So if you got these two as the answer, that's really amazing. Let us move further now. So here we are going to learn about irrational number. So why we are learning about it? Suppose let's take example from your real life. So anything involving some sort of circular measure needs to use the constant pi, which is irrational number. So therefore let us learn more about it. So here a number s is called irrational if it cannot be written in the form p over q, where p and q are integers and q is not equal to 0. So this is the definition of irrational number. Now there are some examples for you, like pi, square root of 2 and so on. So let us see this theorem now. Let p be a prime number. If p divides a square, then p divides a, where a is a positive number. So it's a theorem. So we are going to use this theorem to prove irrational numbers. So let us try this example here. So here we need to prove that square root of 2 is irrational. So first of all, let us assume that square root of 2 is rational. So if square root of 2 is rational, then we can write this in the form of p over q, where p and q are integers and q is not equal to 0. So suppose p and q have a common factor other than 1. So we divide by a common factor to get square root of 2 as a and a over b, where a and b are co-prime numbers. So now they don't have any other factor other than 1. So we can write this as b square root of 2 equals to a when we rearrange them. So a over b we can write in this manner, square root of 2, and this b we can move to that side. So it will become b times square root of 2 equals to a. Now when we square both the side, we will get 2b square equals to a square. Now here 2 divides a square, and by the theorem which we had just learned, 2 divides a as well. So we can write a equals to 2c for some integer c. Now when we will substitute for a, we will get this form here. From this, b square equals to 2c square. This means that 2 divides b square, so 2 divides b also, using theorem 1. Now therefore a and b have at least 2 as a common factor, but this is the contradiction because a and b have no common factor other than 1. So this contradiction has arisen because of our incorrect assumption that square root of 2 is rational. Therefore we conclude that square root of 2 is irrational. So in this manner we can prove that square root of 2 is irrational. Now let us move to a practice time. So here we are going to try number 1. Here we need to prove that 5 square root of 2 is irrational. So again let us assume that this number is rational. So if it is rational, we can write this as p over q, where p and q are integers and q is not equal to 0. So p over q in this manner. Now if we are going to rearrange them, it will become square root of 2 p over 5q. So after this we know that p and q are integers, so therefore p over 5q is a rational number. So if this side is rational, this side is equal to this side. So here 2 square root of 2 will become rational number, but this is the contradiction because we have just proved that square root of 2 is irrational number. So therefore assumption was wrong. So we can prove now that 5 square root 2 is irrational number. So in this manner you can try rest of them. Assuming that you have done it, you can check your answer from these answer slides. So it's for number 1 which we have just done, number 2, number 3, and number 4. So if you got them all correctly, that's really wonderful. You're doing superb job here while learning irrational numbers. So thank you for watching the video. For more, please visit justtutors.com.